Hello and welcome. This is OP-1 and OP-1 Field. In this video, we're going to give an overview and show examples of their synth engines. OP-1 is a digital synthesizer that currently has 12 different synth engines, including the sampler engine. Each one has a unique graphical interface and character. Field has an additional synth engine called Dimension, as well as a vocoder. Each synth engine has several presets available, and you can create your own presets. Each synth engine has parameters that can be adjusted via the 4 color-coded encoders. Parameters vary between the synth engines, and each should be studied individually. Also, it's hard to explain exactly how the synth engines are designed and how to control them. Instead, we're going to show each one, try various presets, and let you hear the general character and range of each synth engine. Just a quick note about our setup here. We've got OP-1 connected to a computer as a sound module. MIDI is being sent to the synth, and audio is being captured directly from each unit via a sound device's mix pre, and there's no additional processing. This allows for a direct comparison between the two OP-1 models and minimizes irregularity and nuances in playing. Another note, you should notice a difference in sound quality between these two units. Field uses a stereo signal path and 32-bit audio processing. Because most synth engines and presets are the same on both units, we should hear a difference in audio quality as well as stereo imaging. Let's walk through each of the engines in alphabetical order. Since we want to hear presets from the synth engine, we will change presets in the sound buttons. Press and hold Shift and then press one of the 8 sound buttons. Use the blue encoder to select the first engine, which is cluster. Use the green encoder to select a preset. Then press the synth mode button to close the list. Teenage Engineering describes this synth engine as up to 6 oscillators chained in a cluster. Here's a list of what parameters the encoders control. On Field, there have been many improvements in sound quality, so let's hear how this synth engine sounds on that device. Let's compare a few more presets. Let's move on to the next synth engine. Press and hold Shift and then press the sound button. Use the blue encoder to select the next synth engine, which is digital, and use the green encoder to select a preset. Again, let's see how this synth sounds on Field. The next synth engine is DNA. Press and hold Shift and then press the sound button. Use the blue encoder to select the DNA synth engine, and use the green encoder to select a preset. DNA is described as a noise synth. What's unique about this synth is that it uses the processor's ID within the algorithm of the synth engine, thereby making a unique sonic signature to each OP-1. Let's have a listen. On Field, the graphics are different, and let's see how different it sounds. The next synth is DR wave, which is described as being frequency domain synthesis. The display shows the waveform of the synth engine. It will update as you play notes on the keyboard and rotate the encoders. On field, the graphics are similar, though in a different color and more refined. D-Synth is a multi-envelope dual oscillator synth. Unlike other synth engines, which have relatively abstract displays, D-Synth gives a full display of settings and corresponding visual feedback. Also with this synth, use the Shift button to access settings, including the second oscillator. FM is a 4-operator FM synth. The display shows 4 boxes with numbers within each one. As we change parameters with the encoders, we will see the graphics change to interpret what's happening with the FM synth engine. And on field. Phase is described as phase distortion. On the display, we see a series of waves that are color-coded to the knobs. In field. Pulse is described as a dual pulse train oscillator. The display shows some useful information, feedback, and the relationships between the parameters. And on field. Sampler is a synth engine that uses an audio file to create a traditional sample-based synth engine. Here, a single audio file is transposed across the notes of the keyboard. The display shows a representation of the waveform of the audio file loaded in the engine. A sample up to 6 seconds long can be loaded into this synth engine. Also, the shift button provides additional functions in this engine. As the name implies, we can record an audio sample directly into this synth engine. Press the Input button to get to the input screen. Use the blue encoder to select an input. Available inputs are the built-in mic, built-in radio, USB audio, resampling OP-1's output, or the line input. Use the orange encoder to set input gain. When ready, press and hold the keyboard and release when finished recording. The sample is now transposed on the keyboard. Use the encoders to adjust start, end, and loop points. Note, in order to save this sample, we need to create a snapshot. Press and hold one of the 8 sound buttons for 5 seconds. The screen will show it saving. This preset will now be available from the snapshot folder. Press and hold Shift and then a sound button. Use the blue encoder to select snapshot and the green encoder to select a specific snapshot. These are time-stamped according to when they were created. Let's return back to the sampler engine and look at some presets. On field, the graphics have been improved, and stereo files can be loaded and recorded. The string synth engine is described as physical modeling of a string instrument. On the display, we see a 3D representation of the synth engine. And on field. Voltage is a multi-oscillator electric synth engine. The display shows a representation of the synth engine in the theme of electricity. On field, the graphics have been improved. Field comes with an additional synth engine called Dimension. The interface is rather intuitive and it sounds great. Field also features a vocoder. The vocoder is different from the other synth engines we saw. It requires an input signal such as a mic, radio, or line input as a modulator signal. This signal gets analyzed and alters a carrier signal, in this case, the synth engine. Press the input button. Use the blue encoder to select the source. Use the orange encoder to set input gain, and press the input button to close the screen. Playing notes on the keyboard, we can hear this in effect.
Tracks to YouTube.
Hey, please subscribe if you learned something. We hope you found it helpful. Check out the description for more videos in this series. Thanks!